So this is problem 31 of chapter 14 of the textbook Stats Modeling the World by the authors BVD. Okay, so this is we're looking at voters and we're conducting a poll. So we're randomly calling voters, and it looks like they're giving us some information. So supposing in your city 37% of the voters are demos. So Democrats 37%, Republicans 29%, and then others, liberal, right to life, right to life, Green Party, boy, yeah, that's all over. So other is 11%. So let's see, if we added those up, what do we get? We get I think 77%. Yeah, 77. Okay, so independence would have to be 23% because we have to add up to 100%. Okay, so that's kind of how I break this down. So now they want to know, I think we're in your first 3 calls. So what's the probability of all Republicans? So that would be the probability of a Republican and Republican and Republican. So again, I want you to see the and. So that's going to be the probability of a Republican times the probability of a Republican times the probability of a Republican. And so that's just going to be 0.29 times 0.29 times 0.29. And that comes out to be, I get 0.024. Okay? So, now, no Democrats. So, what's the probability of no demos? Okay, so let's see. How can we do that? Well, if we wrote it out, that's just, again, to see the and, no demo, and no demo, and no demo. So that's going to be the probability of no demo times the probability of no demo times the probability of no demo. Okay, so what's the probability of no demo? Well, it would be Democrat is 37%, so that would be 1 minus 0.37 times 1 minus 0.37 times 1 minus 0.37. Okay, and then I get 0.25. So 25% of the time. Alright, so that's how you do that. Not too bad. Now here we get at least one independent. At least one independent. So we're going to do 3 draws. So independent not independent, independent, 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 not independent. So again, this is independent, independent, independent. If you've watched my other videos, independent, independent, not, independent, not, independent. You start to see a pattern, or you just, if you do this enough times, like tying your shoes, after a while you don't have to think about it. Here it is, independent, not independent, independent, not independent, then not, independent, independent, not, independent, not, independent, and then finally not. So we want to know what's the probability that there's at least one independent. So we would have to add all of these probabilities up. Or we can exploit the fact that they all the branches add up to 1.0. So we can say probability of at least one independent is equal to 1 minus the probability of all not independent. So that would be 1 minus the probability of not independent times the probability of not independent times the probability of not independent. And I think that we already have right here. That would be, so it would be either a Demo, a Republican, or a Liberal, Right to Life, or Green Party. So 0.77. Okay, so you just punch this up on your calculator and you will get 0.543. I should say I get 0.543. Double check, but I think that's right. Okay, so that's how you do this problem. Kind of interesting. It helps to think about what you've been given first before you dive in. Okay, good luck.